Oh, I have completely forgotten how many cups of coffee I've had today because this is getting tougher and tougher. But then, you can do it. If I can do it, Setu can do it. You guys can definitely do it. For everyone who has come this far, so proud of you. Just continue doing it. And after 30 days, you'll be extremely proud of yourself. For those who have just started it, it's okay. If others can do it, you can do it too. By the way, hi everyone, I am Sneha from the Web3 Compass, and this is day 17 of 30 days of building with Solidity. For everyone who doesn't know what this campaign is about, go to my day 1 video, that is where I talk about it in detail, or go to web3compass.xyz, and here you can find all the challenge details. For the rest, follow me through. Okay, so on day 17, we're going to write a contract. Actually, not one contract. We're going to write like 4 contracts. I know. Don't run away. It's fine. 4 contracts. Even I was scared, by the way. But what we are going to talk about is upgradable contracts, proxy pattern, delegate call for upgrades. This is literally one of the most difficult topics in Solidity that I feel. I'm like, no matter how much you do it, you just always feel that you're missing something. I don't know why. Maybe I've not used it enough. Maybe I've not paid enough attention, but it's important. So, as an example application, we are going to build an upgradable subscription manager for a SaaS-like app. The proxy contract stores user subscription info like plans, renewals, expiry dates, while the logic for managing subscriptions, adding plans, upgrading users, pausing accounts, lives in an external logic contract. When it's time to add new features or fix bugs, you simply deploy a new logic contract and point the proxy to it using delegate call without migrating the contract without migrating any data. And this stimulates how real world app push updates without asking users to reinstall. And you will learn how to architect upgrade safe contracts using the proxy pattern, delegate call, separating storage from logic for long-term maintainability. Now, all of these 4 contracts are going to be very tiny little contracts, and some of it is some of the sections is something you might not be able to get at once, and it's okay, right? Because come on, only practice can make you understand these concepts over time, and you cannot just do it just like that. Okay. Close challenge. Let's head to remix. Before we actually start, to give some initial discussions apart from, what we already had written in the challenges section. Imagine, you have launched a smart contract into the wild. It's running smoothly, users are subscribing, ETH is flowing, and then boom. You discover a bug, or maybe you want to add a new feature because the users asked for it, or the community asked for it, or maybe you want to, just update something. You realize that the logic could be way more efficient, and you can't change a smart contract when it's deployed, right? But at least not traditionally. If in Web 2, you fix a bug or add a feature, you just push an update to your server. But in Web 3, a smart contract is immutable once deployed. It's logged in unless you're designing it to be upgradable. So there's a huge discussion where can we consider is that immutable, mutable, and all of that. I would say we can consider it as upgradable, and you have to design it like that when you know that, it's going to scale, users are going to come in and all of that, right? So now what does upgradable mean? When we say upgradable contracts, we're talking about separating storage from logic. So the idea is you deploy one contract that stores the data. We'll call it the proxy. You deploy another contract that holds the logic. This is the actual code, actual implementation of it. The proxy uses delegate call that to execute logic from the external contract, but on its own storage and not on the contract storage. So if you ever need to change behavior, you don't touch the proxy. You just point it to a new logic contract and all that data stays safe. And once we deploy it, we'll show you how that works, right? So now what are we building? When I say that we are writing 4 smart contracts, we're going to write since we're building a subscription manager, a modular subscription manager for like a SaaS kind of dApp, we're saying subscription storage layout.sol, subscription storage.sol, subscription logic version 1, and then subscription logic version 2. Okay. Now these are really big names. I will create the file for it. Okay. So when I say subscription storage layout.sol, this is going to be the blueprint. It defines who the owner is, where the logic contract lives, the actual storage layout like user subscription, prices, duration, all of that. Think of it like a shared brain that both the proxy and the logic contracts understand. Okay. Now the other thing is going to be subscription storage.sol. So we'll create all the files now only. Okay, now this is the proxy contract. I will just make sure that I add proxy to it. Okay, yeah. And then it owns the data. It delegates the logic to an external call contract via delegate call, and it can upgrade to a new logic at any time. So the users are actually going to interact with this contract. But behind the scenes, it's just forwarding their calls to whatever logic the contract is currently pointing to, okay, or whatever it is that the user is asking for. Now, subscription logic V1 is the first version of our logic. We are going to add subscription plans, let users subscribe, check if a user is active, so on and so forth. Wait, let me just... I have all of these written so that I don't make 100 typing mistakes while writing the file name. And the other one is where we are building a version 2 for the logic. And what we do here is, it is an upgraded version with extra powers, everything from V1, but now you can pause or resume user accounts in terms of the subscription. We'll switch to the proxy, we'll switch the proxy to point to this contract when we are ready to upgrade. Okay. Now, why the setup is powerful again? I think we've already talked about it, that let's say you've got thousands of users subscribed, the subscription info is saved in the memory, and then you realize, oh my God, I want to let users pause their subscription. I've not added this feature. Now, would you ask them to reinstall? No. So in a non-upgradable world, you are stuck. You would either deploy a new contract, lose all of that data, or migrate everything, which is a hassle and not user-friendly. But here, you simply write a new logic contract, which is going to be our version 2 with the pause and resume features, and call upgrade 2. No migrations, no downtime, no user impact. So in the next sections that we're going to talk, we'll go one contract at a time, explain what it does, how it works, as we always do. And let's get started with the most smallest contract. Okay, but let me just quickly copy this. Oh, zoom. Yeah. Okay. So we'll close this one. Now we're starting with storage layout. Again, same thing. Now we're saying contract. See, I've started making a mistake. Subscription storage layout. Okay. Now, we're saying that this, with what we're saying, this is going to be layout of, how the storage is going to look like and all of that. So this is going to be a standalone contract that only holds our state variables. It does not include any functions except for the inherited logic later. The idea is to separate storage from logic, which is the key part of the proxy upgrade pattern. Now, this layout acts like a blueprint that defines the memory structure for both the proxy and the logic contracts. And by importing and inheriting this layout, both contracts can share and manipulate the same data, assuming it's in the same memory layout order, which is critical for delegate call to work correctly. So what is it that we're trying to say? We're just saying, hey, generally we write a contract, we talk about state variables. Neha, you always get started with address and uint and then go to mapping, blah, blah, blah. And then we get to functions. But here, we're going to talk about the variables, the mappings, talk everything storage, but we're not going to talk any function implementation. Okay. So let's just get started. The first thing, okay, we're going to store the address or declare the address for the logic contract. Like, how else is the, interaction going to happen? So it will store the current implementation address. The logic contract will be the one where the functionality actually lives. Okay. It is used by the proxy contract to know where the forward calls using delegate call. And you can update this address later via the upgrade to. That is why we're writing two contracts here, logic V1, logic V2. When I run this entire thing, you will know how we're actually working. But the overall idea is that this logic contract first would be the contract of logic V1. Okay, that is our first version of contract. And then we'll see the interaction via the proxy contract. And then you're like, okay, it's time I add more features. So I tell you, hey, write another contract which has logic V2 or version V2, right? And then we go to the proxy contract. There will be an upgrade to feature which tells the contract that, hey, it's time we move to another contract and upgrade or move all the calls to that side. So that is where we put the deployed address of logic V2 and we start interacting. Okay, it's that simple. Then we're saying, okay, address public owner. Now, this is something that you already know, right? So this will keep track of the admin or deployer of the contract, the only one who can actually upgrade to new logic versions. You could expand this later with role-based access control, multi-sig ownership. We've done it. Come on, we've restricted it. We've done transfer ownership and blah, 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 right? Now we'll write the subscription struct. Again, remember, we're just talking storage here. Subscription. Okay. So we're saying uint8 plan ID. Okay. Then we're saying uint 256 expiry. And then we're saying bool paused. Okay. So uint8 plan ID identifier for the user's plan is small, like 1, 2, 3 to represent different tiers, basic, premium, blah, blah, blah. Again, everyone who has looked at gas optimization for, I think, day 15, that it saves gas compared to uint 256. Then while uint 256 expiry, we're talking about a timestamp indicating when the subscription runs out. Now we're using uint 256 here because Unix timestamp large numbers, and bool paused is just a toggle to temporarily deactivate a user's subscription without actually deleting it. Useful for allowing users to pause or resume their plan. Okay. Now we're looking at subscription mappings. So we're saying mapping, what will the mapping be from? Address of the user, obviously, with the struct, right? And then we say public. Okay, let me just write it, right? Subscriptions. Great. Now this is very simple. Each user address gets their own subscription object. This allows us to track each user's active plan, its expiry and pause status. Okay. Now the next thing is that we're going to do something as plan prices. So we're saying mapping, and then we say uint8 with the plan ID. I mean, it would be actually uint 256 because we want to, define the entire thing. So we have said plan ID with the prices. Okay, that is the mapping. You can do otherwise as well. Plan prices. So we're saying how much ETH can each plan cost. For example, plan prices for 1 is 0.01 Ether, for 2 is 0.05 Ether, blah, blah, blah. Okay. Now, now we're saying there should be another mapping UUPS to 256, which is again plan duration. How long will each plan last? So again, we're doing it with plan ID, right? So UUPS with UUPS256. Okay, and then we're saying public plan duration. Okay, great. So this is that. That's it. That's all I could think of in terms of, the implementation right now, with the basic implementation that we're looking at. So now we will go to the proxy contract. Now you should know. Okay, I'll copy this first. Oh my God, what did I do? Did I not? Oh, did I write it in the wrong one? I am so sorry, guys. I'm here at Logic V2 and I'm so sorry. We had to write it in storage layout. I'm extremely sorry for that. Yeah. Okay, this is clear now. Logic V1 is clear and it's time for proxy. Okay, so let's just copy this entire thing, okay, and go to proxy. Okay, now the first thing, those who have followed through, you know that you need to import the contract. We're saying, come on AI, come on, tell me. Subscription, storage, layout. That's all. Yeah. And then we are writing contract. Okay. I'll just copy it from. Okay. Contract, subscription, storage, proxy is again this entire thing, because we're using the is keyword to import it. Now, everyone who has stayed with us in this 17 days, you know what we're talking about. So smart, guys, very smart. Now, what is it that we're going to do here? The headers are clear, right? And you know that we will import the shared storage layout here. This makes sure that the proxy has the same variable structure as the logic contract. If you remember, delegate call means code runs from logic contract, but storage belongs to proxy. Okay, that is why we did not talk about any implementation in the storage section, but they both are going to share the exact same layout. Okay. Now, we define the contract called subscription storage proxy. This is not where your business logic will actually live. This is the contract users will interact with to actually interact with your logic. But it will delegate all real work to the logic contract. And that is how you can remember the delegate call to the work delegation. That means to the real contract where the logic stays. And it inherits from the subscription storage layout, meaning it now owns the logic contract, the owner, all the mappings. And this is where we're going to get started with the modifier first, because we have to check some. Oh, no, not this. Okay. We're saying modifier. Again, very quickly, how do we do? Only on, everyone should know this, okay? Require a message dot sender equals to owner. Great. Otherwise, not go. Okay, I have talked about how a modifier works again every time, same. How the modifier actually works, and when you're looking at in terms of a function, like how is it placed and all of it, what does this underscore mean? So go back to the old videos. I don't know in which one did I actually talk about it. Okay, yeah. Now that we've written the modifier, let's go to a constructor. Again, everything that we know that needs to be done only once will be here. So we say address, logic, contract, right? And then we're saying owner equals to message.sender, and the logic contract is going to be the logic contract. So this underscore logic contract. So this is the function that runs once when the proxy is first deployed. The owner, simple owner line is very clear. Logic, you pass in the address of your initial logic contract. Usually it would be version 1. That is what we're talking about. And now your proxy knows which logic to use when users start interacting with the contract. Okay. Now we'll write the function upgrade to, which I was talking about. So we're saying, okay, upgrade to, and what? The address of the new logic, right? Now this is actually new logic contract, but I'm writing it as new logic. It's self-understandable. And this has to be done by only owner. Now let's get started. Now what we'll do this logic contract is equals to new logic. That's it. That's all that we had to do here. Okay. So this is the function that will actually make the entire upgradable architecture possible. Once we write the logic v2 and we deploy it, the proxy contract will point to a new contract, which is a subscription logic v2, protected with only owners. Only the deployer can upgrade. When this happens, the storage stays the same, but all new interactions will use the new logic. Now, why is it powerful? Because you can fix bugs, you can add features, refactor code without ever touching user data or asking people to redeploy. Okay. Now what we're going to write is a very weirdly complicated stuff. I mean, it stays same throughout, like most of the cases. Everywhere I've seen a proxy contract, this is like very similar. And basically we're going to write the fallback function, and there's an assembly section in it. I'll talk about it. Okay, so now what is fallback? Okay, I know we're talking about it the first time, and every time we talk about something new, it is just very, very scary, right? So this is how we write it. It's a special function that gets triggered whenever a user calls a function that doesn't exist in the proxy contract. Okay. That's perfect because, you know, this proxy contract anyway does not have a logic of its own. So this gets triggered every time users try to interact with a function in our other contracts like subscribe or is active. Okay. Now you will see something as an inline assembly and, you know, the assembly part of things. So let's get writing, right? So we're saying, okay, address implementation. I'm writing it as short, implementation logic contract. Okay. We'll check condition that says require, and that this implementation address is not actually an address 0. Okay. If yes, then logic contract is not set. If it is not, then, if it's not an address 0, it's fine. Ugh. I hate it. Okay. So yeah, that is the condition that we will check. Okay. So this is self-understandable. Okay. And we're going to, store that logic contract in implementation. Okay. Now this is where the assembly part comes in. Again, very, low level thing. Everywhere that you read about assembly, you are going to see or hear about YieldFarming, which is again assembly level stuff, low level stuff. That's like entirely different thing when we talk in terms of, Solidity and entire language in itself. But whenever you talk proxy contracts, you will see something very, very similar every time. Okay. So we'll write something called as call data. Okay. Copy. And we're giving some parameters here. And we're saying, okay, this is how we actually copy the input data, which is the function signature plus arguments to a memory slot 0. Okay. Then we'll run this main event where we're saying, hey, run this input on this logic control implementation, logic contract implementation, where we're saying let result. Again, a little bit of syntax difference here. So don't get overwhelmed. Anywhere that you search for proxy contract. In fact, I shared a link with Solidity by example. I will add it in the description also. You will see a similar kind of, implementation happening. So you can just consider it as a template. Okay. This is how it's going to look like. Okay. Yeah. So it says, okay, call implementation to update this subscription data structure. But we are saying, hey, run this input on logic contract implementation. So the delegate call will run the logic code, but then uses this proxy storage and this proxy context. Now, we're not going deep into what each of these is going to mean, because again, a lot of things to understand there, but just remember that this is how we provide things, and again, same everywhere. Okay. Just a little bit of maybe change in the names and all of that. And then with return data copy, we're saying, hey, copy whatever came back as the result or came from the logic contract's execution to memory. And it could be a return value or an error message. And for that, we will use a switch case. Yeah, I've never really seen that, while writing Solidity. But says switch result. And we say, okay, if it's case 0, revert 0, and then, revert 0 and then return data size. Okay. If it's case or the default case, right? Then use, again, then also you return. Oh, sorry. So in case 0, you say revert 0, return data size. So that means if the logic call failed, we revert and return the error. Otherwise, we return the result back to the original caller as if the proxy contract has executed itself. Okay. So this remains same. Data sets. Okay, great. So even if you go here, Solidity by example, and we talk about not minimal proxy, upgradable proxy, you will see a section in the contract proxy where we say, hey, function delegate, address implementation, internal virtual, assembly section starts, call data copy 0,0, call data size. So we're saying, hey, the call data copy has TFS, copy S bytes from call data at position F to memory at position T. And call data size is the size of call data in bytes, right? And then you're calling the implementation, and then it explains everything that, hey, let result delegate call, there's gas, there's implementation. We have used IMPL 0, call data size 0,0. Now you will see what each of these means. So it says delegate call G, A, in size, out size. So call contract at address A. That means at implementation, which had the logic contract with input memory in plus size, right? So in and this in size, right? Then we're saying providing G gas, right? That means 0 and then whatever. And output area, out plus out size. And then returning 0 on error, example out of gas, and 1 on success. Okay. And then you return data copy 0,0, return data size. Again, there's a pattern, return data copy T, F, S. So you're copying S bytes from return data at position F to M at position T. Blah, blah, blah. Overwhelming. But what I want to tell you here is that this is the exact same thing that we have written So you can just take it as a template if it feels very, very overwhelming for you to, understand the entire thing. And then once we are out of this, where did this is here, right? And then we write a receive function, external payable, okay. Oh, wrong spelling. Yeah. Okay. So we're saying that this is going to be more of a safety net for the entire contract to, a safety net that lets proxy accept raw ETH transfer. You may not need it here, but it's often useful when the contract is receiving ETH directly during a payment. Now, there's an entire section which talks about that when is a receive called, when is a fallback called. Again, we'll talk about it in the coming section. And this is good. Okay, so let's just compile this. Okay, it's compiling, fine. Subscription storage was also, compiling. Okay, great. Now we'll go to writing the subscription logic V1. So we will copy this entire thing here. Okay. Again, we have to follow the same storage pattern here. That is why we're writing it like that. Everything remains same. And we're saying, okay. Contract, subscription, logic, V1 is storage layout. Great. So we're defining the logic contract and inherit from subscription storage layout. So we get access to the proxy storage when this contract is called delegate called, right? And this contract will handle adding new plans, subscribing users, checking active status. So we'll directly jump into writing the function, which is my favorite part. So we're saying function add plan, okay, uint8 plan ID, okay, and then uint256 price, comma, uint256 duration, okay, again keeping it external, and then we're saying, okay, plan prices, right, of a particular plan ID, okay, is equals to price. Okay, now each plan ID has represents a unique plan. Now you can say 1 is basic, 2 is pro, 3 is premium. We store the price of the plan in plan prices, right? We had created it there. And then we are saying that if you want to check the plan's price, you give the ID for that, and that is what the price is set up. And then for plan duration, right, you give a plan ID, and then you say, okay, this is the duration that it is active for. Okay, that's it. Why this is useful? This makes the subscription system customizable. You can define multiple plans with different pricing structures and durations. Since this contract can be upgraded, the plan model can evolve over time too, but we're writing a basic implementation here. Okay, now we'll write the subscribe function. Okay, function subscribe. Okay, great. So subscribe to what? Plan ID, obviously, right? uint8 plan ID. Okay, external, and now here is where payments can happen. So we'll make it payable, and that's how we're going to do it, right? So we're saying check conditions like require the plan prices of a plan ID is greater than 0. If yes, great. Otherwise, maybe invalid. Okay. Then other thing is require is the message dot value provided greater than or equal to plan prices, plan ID, otherwise insufficient funds or insufficient payments, right? Because that is how we're going to pay. Now, we had created a subscription struct there. So we're saying subscription storage. Yeah, let's take it as S right? And we're saying subscriptions message dot sender. Okay. Now what does this line do? So we're fetching the caller's subscription record from the subscription mapping. So message dot sender is the address that we're talking about here. So we'll check for the, subscription that it has, right? And we will say that, hey, we're going to do now two cases here, that if block.timestamp, like we'll check for the expiry, what is the current timestamp, is it paused, is it not, and all of that. So we're saying, if, okay, block dot timestamp is less than s dot expiry, okay, we're saying what s dot expiry, okay, plus equals to, and what is it that we'll add? We'll add the plan duration for that particular plan ID. Okay, so we're saying if the user already has time left, okay, that means block dot timestamp is less than s dot expiry, add the new duration to the current expiry. This lets them extend the subscription. Otherwise, that means else, we're saying s dot expiry is equals to block dot timestamp plus plan duration, plan ID. Reset the expiry to now plus duration. That means it's a fresh subscription, right? Whatever is the block.timestamp currently, you just add the plan duration to plan ID. Now, what will you do after this? You will say s.plan ID is equals to what? Plan ID. Okay, that means for this particular user that we have created, this is the plan ID, and put s.paused equals to false. Why? Because the subscription is currently running, right? So it is recording the plan that they close, unpause the subscription by setting it to false. If you pause it, it should be true. Now, why is this smart? Simple. Gas efficient, supports both new and existing subscribers in one function, because we're also talking fresh subscription and we're also talking the old ones. And it automatically resumes past subscriptions. Again, useful for things like version v2 that we are thinking of writing, right? Now, we'll write the last function here, which is function, not this way, God, come on. Function is active, okay? And then we say, okay, no. We're saying address of the user, right? And then we're saying, this is going to be, again, just a helper function kind. And we're saying bool, right? Because is active, you know what it is going to return. And then it's just quickly saying that, hey, check the subscription struct, okay? We need it in the memory. So we're saying subscriptions, and then we're saying this user, and then return what? Block dot timestamp. It's checking to what? S dot expiry. And then it's not paused. Oh, and then ampersand. Okay, that's it. Okay, so it's saying it will return true only if the current time is before the subscription's expiry and the subscription isn't paused. Okay, now why this matters? Again, this is read-only helper you would use in front ends, gatekeeping across to premium features, displaying renewed prompts, and all of that. That's it. Okay. Okay, everything's compiling fine. Now it's time we copy this again, entire thing, and go to subscription logic v2. Okay. Okay. Yeah. Okay, we'll just change this to V2 and add this here. Okay, everything here, again, I'm not going to explain what we did here right now. You should be aware. Now, we'll just directly jump into what upgradation that we need. Okay, like if you want to add or upgrade a subscription plan, where we'll be using the plan ID as the identifier, store how much it costs, how long it lasts. It is same as V1. We didn't change anything here because it already works well. Again, we'll just have two sections that we're going to actually write. So we'll just copy this entire thing from here. Okay. So with these these three. Okay. This entire thing, I mean, the best. Yeah. Okay. So this entire thing remains same. Okay. Same as V1. Again, the subscribe thing is also again same as V1. Now you have to understand, someone would be like, hey, why could you just not inherit it? I mean, we're talking about upgradation, right? So we're changing it in the code base. Now you won't need the version 1 once version 2 is out, right? And you have to make sure that previous all the things remain the same. It's just because we're running it like this, we want to show you a difference that, okay, this is V1. Now you want to add certain things. So that should be V2. That is why we had to show you like this, right? But otherwise, everything here is same. We need to go to writing new function. Suppose we want to pause account. Okay. We're saying function pause account. Now, I hope everything is clear on this front that why we repeated certain functions. And we're saying, okay, this is version 2. And this is what the proxy contract will, interact with once we upgrade. Okay. Now, what we do is we say, hey, subscription dot paused. Okay. Actually, no. Subscription for that user dot paused equals to true. Okay. So it will manually pause a user's account, could be used by an admin or delegated to the user themselves in a future version. Now, why it would matter again, some users may want to freeze the subscription temporarily, or as an admin, you want to suspend an account due to abuse, payment failure, etc. It does not touch expiry. So the clock will still tick, but the account is blocked from access. Now, we'll add another angle, very small function called as resume account. Okay. Now again, I am specifying this, that this is an upgraded version of it. We're just writing it as another contract to show you how we can upgrade the entire thing and let the proxy contract talk to it. Okay. So we're saying dot paused equals to false. That's it. Okay. So re-enables a pause subscription useful when the user wants to resume or the admin wants to re-enable after resolving an issue. If it was a payment failure, blah, blah, blah. Now, how do we go and, run the entire thing? So let's just also compile this. Now, one by one, we will deploy these. Great. Storage layout is deployed. Okay. We will also deploy the proxy. Okay. There's an input contract here that is required. It's like address logic contract, right? Yeah. So in this section, you need the logic contract here. Now, what we have to do is we have to first deploy this. Okay. Now we'll copy the address from here and then we'll go to the proxy contract and say, hey, this is the address of the contract. Again, subscription logic. This is the address. And then you say at address and then you get the subscription storage. Oh. Okay. This is the proxy. So now, if you go to the logic section, there's a upgrade to, right? In the proxy, upgrade to, and then there's logic contract. So you will see this is the logic V1 is deployed here. Let me just okay. So that is the address that you will get. And the owner is the person who's calling it and all of that. Okay. Now, okay. Now, once you've done that, okay, once you've deployed it, you go back to the subscription logic V1 in the contract editor. In the input box to deploy, paste the V1 logic address inside the quotes, okay, and click deploy. So now you have a proxy which is wired to your first logic contract, okay. Yeah, this is logic contract, this is the owner, etc. Now you have to interact with the V1 via the proxy, okay. So now you have to, in order to do that, this is how you're going to interact, okay. Make sure that we are on the logic one. So here it shows, okay. And select subscription logic in the contract editor. This will allow Remix to automatically pick up its ABI. In the input box, paste your deployed proxy address. Okay. So first what we did was we deployed V1. We got an address. We went to the proxy contract. We added that address, add address thing. Okay. And then we'll run this. You will see what happens here. So I'll close this one part. There was storage layout. There's logic V1. There's subscription to proxy. Now, once I do add address, there's another logic V1 created, right? So a new instance of V1 will be deployed and now you can interact with it. Now you will be able to see add plan, subscribe, is active, logic contract, owner. When you were looking at this one, this had everything here, but the proxy one had only these, right? Only these functions. Now with that proxy contract coming in, there's a new instance of V1 generated. And then if you check the logic contract, it's the same address. The owner is that person. And now you can say, okay, add plan. Let me add plan ID as 1, price as 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's like 0.1 ETH. No. That's like 10 to power 9 V. Yeah. And duration is like 300 seconds. Okay. So I transact. Where's my terminal? Yeah. Right. So here is the thing that's happening. Okay. We just have to keep it good enough so that you can see it. Now, if you check the plan duration for 1, 300, plan prices for 1, again this subscription at address. So let me just copy this address, which is of the user. So you say, okay, plan ID. Oh, I didn't actually subscribe. So I want to subscribe. And then if you run subscriptions, oh, sorry guys, subscribe and you want to give 1. Okay. Oh, I didn't have enough funds because I did not give enough values here. So 3, 4, 5, 6, 7, 8, 9, 10, whatever. And then I say subscribe and it goes through. And then if you run subscription, you will say plan ID, expiry, paused, false. Right? Now this is done. This is how you are interacting. So you will now see V1 functions and all of that. You're giving value 0.01 ETH or whatever value that you want to give, right? Yeah, if you give the address of the user, you will see that the subscription is, true. So this is the interaction by the proxy. You saw how the entire thing, worked. Now, let's close this. And now we'll go to subscription logic V2. Okay, now here it has changed, and this is our proxy address, right? Okay, so we have deployed it. Now I'll copy this. Okay, copy this, go to the subscription storage instance and all of that. Now we want to go to the proxy instance and we say, okay, upgrade to address new logic. Upgrade to. Okay, so it went through. Now if you change, the logic contract will change. Okay, how did that happen? Let me just show you what is the logic of V2. That is the address, right? So this is the address, and now the logic contract has changed. Okay, and after that, this tells the proxy to now use the V2 contract for the logic, and now you want to use the V2 features via the same. So now you go to the great. So now you will select the subscription logic v2.sol at the contract editor. So this is here, and you will paste the proxy address. I think this was the address, right? Yeah, same one, right? Now once you, okay, let me close this, right? So there's logic v1, this was the first deployment, there was a proxy, and this was a new instance. Then there was a v2. Now when we click deploy, there will be a new instance of it, and then you will see pause account, resume account. So this is how you're going to interact with it. So if I, if I just copy it from here, pause account, transact, and then let's check is active. So it becomes false. Here previously, no, not V2, right? It is V1. Here is active was actually true, right? But now we're talking with version 2. And then we'll check for subscriptions. There's nothing, right? Because we've paused it. Now I want to resume account. So I'll say resume account, and then I'll run subscription. So the pause is false, but I've not subscribed to anything yet. Again, that 300 seconds has been over. So I was like, oh, there's an invalid plan. Now you have to add the plan because it was only valid for 300 seconds. So maybe just say 2 prices, 3, 4, 5, 6, 7, 8, 9, 10. And then again, maybe 600 seconds. And I transact. And then I say, hey, let's just subscribe. Oh, again, sorry. Same mistake. 3, 4, 5, 6, 7, 8, 9, 10. And I say, can I just subscribe? Okay. Then you check is active. It's true. Right? Plan duration for 2 is 600 seconds. Plan prices is this. And then check subscription. So it says 2, and this is the timestamp, and paused is false. Again, I would want to just pause account, transact, and then check it's true. Right? So that's how you do it. It's a little confusing, not like our traditional deployments and all of that stuff. But then that's how it works. Once you start doing it again and again, it will just be fine. So that's it. You deployed a logic contract to V1, routed calls through a proxy, then upgraded to a new logic contract, which has initial set of functions similar to V1, and then new functions as well. Preserved all of that data in the same storage, and yeah, that's it. So welcome to the world of upgradable smart contracts. Same patterns used by giants like OpenZeppelin, etc. And that's it. That's it for day 17. I'll see you on day 18. Till then, keep building. Don't give up. And if you're not on our Telegram group, please hop on. That is where we can just be there at your service 24/7. Bye guys. Happy building.